bathroom vanity light can indeed be on the same circuit as the dedicated ground fault circuit interrupter GFCI outlet if another light such as a ceiling fan with a light is on its own circuit. The National Electrical Code (NEC) mandates that all GFCI outlets in bathrooms be on a dedicated circuit. However, this dedication applies specifically to the GFCI outlet itself. It ensures that the GFCI outlet isn't sharing its circuit with other general use receptacles or appliances. The purpose of this regulation is to enhance safety by minimizing the risk of overloading the circuit and to ensure the GFCI functions correctly by not being affected by other loads. The NEC does not explicitly require the vanity light to be on its own dedicated circuit. This leaves room for flexibility in how the bathroom's electrical system is designed. In numerous situations, it's perfectly acceptable and compliant with code to have the vanity light on the same circuit as the GFCI outlet. This is primarily because the simultaneous use of the vanity light and devices plugged into the GFCI outlet is often infrequent. For instance, it's unlikely an individual would be operating a high-power appliance like a hairdryer plugged into the GFCI outlet while simultaneously using the vanity light for tasks such as brushing teeth or applying makeup. However, there are scenarios where sharing a circuit between the vanity light and the GFCI outlet might not be the most prudent approach. Conversely, in smaller bathrooms where the electrical demand is concentrated, or secondly, in bathrooms where multiple hydro appliances are frequently used in conjunction with the GFCI outlet, it could be beneficial to place the vanity light on a separate circuit. The rationale behind this is to mitigate the possibility of overloading the circuit. An overloaded circuit can lead to trip breakers, which is inconvenient, or in more severe cases, it can pose a fire hazard. The decision of whether to combine the vanity light and GFCI outlet on a single circuit or to separate them ultimately rests on several factors, including the size of the bathroom, the anticipated electrical load, and local electrical codes. If you're uncertain about the best course of action, it's always advisable to seek guidance from a qualified and licensed electrician. An electrician can assess the specific circumstances of the bathroom, evaluate the existing electrical infrastructure, and provide informed recommendations to ensure safety and code compliance. When evaluating whether to place the vanity light and GFCI outlet in the same circuit, it's important to consider the total ampacity of the circuit. Typically, bathroom circuits are either 15 amps or 20 amps. A 15 amp circuit can handle a maximum of 1800 volt amps, while a 20 amp circuit can handle a maximum of 2400 volt amps. It's crucial to ensure that the combined load of the vanity light and any devices plugged into the GFCI outlet does not exceed the circuit's capacity. To calculate the load, add the wattage of the vanity light to the wattage of any appliances that are likely to be used simultaneously. If the total wattage exceeds 80% of the circuit's capacity, it's advisable to place the vanity light on a separate circuit. For example, if you have a 15 amp circuit, 80% of its capacity is 1440 volt amps. If the vanity light consumes 200 watts and you anticipate using a hairdryer that consumes 1200 watts, the combined load is 1400 watts, which is close to the limit. In this case, it would be prudent to place the vanity light on a separate circuit. It's also essential to consider the type of wiring used in the bathroom. Older homes may have wiring that is not rated for the same amperage as newer wiring. If you have older wiring, it's important to consult with an electrician to ensure that it can handle the load of the vanity light and GFCI outlet. The electrician can also inspect the wiring for any signs of damage or deterioration and recommend any necessary repairs or upgrades. Furthermore, it's crucial to ensure that the GFCI outlet is properly installed and functioning correctly. A GFCI outlet is designed to protect against electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path, such as through a person's body. When a ground fault is detected, the GFCI outlet will trip, cutting off the flow of electricity. It's important to test the GFCI outlet regularly to ensure that it is working properly. To test the outlet, press the test button on the outlet. The outlet should trip and the reset button should pop out. If the outlet does not trip, or if the reset button does not pop out, the outlet is not functioning correctly and should be replaced. In addition to the NEC requirements, local electrical codes may have additional requirements for bathroom wiring. It's important to check with the local building department to ensure that you are complying with all applicable codes. The local building department can also provide guidance on the best practices for bathroom wiring. Moreover, when installing or modifying electrical wiring in a bathroom, it's essential to follow all safety precautions. Firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear rubber gloves and eye protection to protect yourself from injury. Fourthly, never work on electrical wiring when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical wiring, hire a qualified electrician to do the work. In summary, the decision of whether to place the bathroom vanity light in the same circuit as the dedicated GFCI outlet depends on a variety of factors, including the size of the bathroom, the anticipated electrical load, the type of wiring, and local electrical codes. If you are unsure about the best course of action, consult with a qualified electrician. The NEC provides specific guidelines for electrical installations in bathrooms to ensure safety and prevent electrical hazards. These guidelines address various aspects of bathroom wiring, including the placement of receptacles, lighting fixtures, and GFCI protection. Section 210.8 of the NEC requires GFCI protection for all 125 volt, 15 amp, and 20 amp receptacles installed in bathrooms. This requirement is intended to protect against electrical shock in wet environments. The GFCI outlet should be readily accessible and located in a place where it can be easily tested and reset. Section 210.11 C3 of the NEC requires that each bathroom branch circuit supply only the bathroom receptacles. This means that the bathroom receptacles cannot share a circuit with other outlets or appliances outside of the bathroom. However, the NEC does not prohibit the bathroom vanity light from being on the same circuit as the bathroom receptacles. Section 410 of the NEC provides requirements for the installation of lighting fixtures. These requirements address various aspects of lighting fixture installation, including the type of wiring, the mounting of the fixture, and the grounding of the fixture. It's important to follow these requirements to ensure that the lighting fixture is installed safely and correctly. Section 404 of the NEC provides requirements for the installation of switches. These requirements address various aspects of switch installation, including the type of switch, the location of the switch, and the wiring of the switch. It's important to follow these requirements to ensure that the switch is installed safely and correctly. In addition to the NEC requirements, there may be local electrical codes that apply to bathroom wiring. It's important to check with the local building department to ensure that you are complying with all applicable codes. The local building department can also provide guidance on the best practices for bathroom wiring. When installing or modifying electrical wiring in a bathroom, it's essential to follow all safety precautions. Firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, use insulated tools to prevent electrical shock. Thirdly, wear rubber gloves and eye protection to protect yourself from injury. Fourthly, never work on electrical wiring when you are wet or standing in water. Fifthly, if you are not comfortable working on electrical wiring, hire a qualified electrician to do the work. In summary, the NEC provides specific guidelines for electrical installations in bathrooms to ensure safety and prevent electrical hazards. These guidelines address various aspects of bathroom wiring, including the placement of receptacles, lighting fixtures, and GFCI protection. It's important to follow these guidelines and any applicable local electrical codes to ensure that the bathroom wiring is installed safely and correctly. When in doubt, consult with a qualified electrician. Consider the specific requirements outlined in NEC Section 210.11. C3 for bathroom branch circuits. This section emphasizes that a 120 volt, 20 ampere branch circuit is to serve bathroom receptacle outlets. This ensures adequate power for the devices typically used in bathrooms, like hair dryers and styling tools. However, it's crucial to understand that while this dedicated circuit is primarily for receptacle outlets, the NEC does not explicitly forbid other loads within the same bathroom, such as lighting, from being connected to it. Local codes and the overall load calculation should always be taken into account. Furthermore, when assessing the load on a bathroom circuit, refer to NEC section 220 for load calculations. This section provides guidance on how to calculate the branch circuit, feeder, and service loads for various types of occupancies. For dwelling units, the NEC specifies a minimum lighting load based on the square footage of the dwelling. This ensures that the electrical system is adequately sized to handle the lighting needs of the home. Additionally, when calculating the load for receptacle outlets, the NEC allows for demand factors to be applied. Demand factors are percentages that are applied to the calculated load to account for the fact that not all appliances and devices will be used simultaneously. This can help to reduce the overall load calculation and potentially allow for the vanity light to be connected to the same circuit as the GFCI outlet. Keep in mind NEC section 314, which covers outlet boxes, conduit bodies, and fittings. When adding or modifying electrical circuits in a bathroom, it's important to ensure that the outlet boxes and conduit bodies are properly sized and installed. The NEC specifies the minimum size of outlet boxes based on the number and size of conductors that will be installed in the box. It's also important to ensure that the outlet boxes are securely mounted and that the conduit bodies are properly supported. In addition to the technical aspects of bathroom wiring, it's also important to consider the aesthetic aspect. When selecting lighting fixtures and receptacles for a bathroom, it's important to choose products that are both functional and visually appealing. The lighting fixtures should provide adequate illumination for the bathroom, and the receptacles should be conveniently located and easy to use. It's also important to choose products that are durable and resistant to moisture. Bathrooms are typically humid environments, so it's important to choose products that can withstand the moisture. Consider moisture-resistant or waterproof fixtures and outlets. Ensure that all electrical components are properly grounded to prevent electrical shock. Grounding provides a path for fault current to flow back to the source, which will trip the circuit breaker and de-energize the circuit. In summary, determining whether a bathroom vanity light can share a circuit with a dedicated GFCI outlet involves careful consideration of the NEC requirements, local electrical codes, the anticipated electrical load, and safety precautions. Consulting with a qualified electrician is always recommended to ensure compliance and safety. They can assess the specific circumstances of the bathroom, evaluate the existing electrical infrastructure, and provide informed recommendations. Always prioritize safety and ensure that all electrical work is performed by a qualified professional. Consider potential future needs when designing the bathroom's electrical system. If there is a possibility that additional appliances or devices will be used in the bathroom in the future, it may be wise to install a separate circuit for the vanity light to avoid overloading the existing circuit. This will provide more flexibility and prevent the need for costly electrical upgrades in the future. Before making any changes to the bathroom's electrical system, it's essential to obtain the necessary permits from the local building department. Permits ensure that the work is performed in compliance with all applicable codes and regulations. The building department may also require an inspection of the work to ensure that it meets the required standards. Failing to obtain the necessary permits can result in fines and penalties. Always check your local and most recent NEC guidelines as they are updated every 3 years. Consider also energy efficiency when selecting lighting fixtures for the bathroom. Energy-efficient lighting fixtures, such as LED fixtures, consume less energy and can save money on electricity bills. They also generate less heat, which can help to reduce the load in the bathroom's air conditioning system. When selecting LED fixtures, it's important to choose fixtures that are rated for use in wet locations. This will ensure that the fixtures are protected from moisture and will last longer. Also, consider the color temperature of the lighting fixtures. Color temperature is a measure of the warmth or coolness of the light. Warmer color temperatures, such as 2700 Kelvin, produce more yellow light, while cooler color temperatures, such as 5000 Kelvin, produce more blue light. The best color temperature for a bathroom depends on personal preference. However, warmer color temperatures are generally preferred for bathrooms because they create a more relaxing and inviting atmosphere. Consider the impact of lighting on the bathroom's overall design. Lighting can be used to create different moods and effects in a bathroom. For example, recessed lighting can be used to create a clean and minimalist look, while decorative lighting fixtures can be used to add personality and style. It's important to choose lighting fixtures that complement the bathroom's overall design. Consider the use of dimmers to control the brightness of the lighting fixtures. Dimmers allow you to adjust the brightness of the lights to create different moods and effects. They can also help to save energy by reducing the amount of light that is used. Dimmers are available for both incandescent and LED lighting fixtures. If you have any doubts or concerns about the safety of the bathroom's electrical system, it's always best to consult with a qualified electrician. An electrician can inspect the electrical system and identify any potential hazards. They can also provide recommendations for improving the safety of the electrical system. Prioritize safety above all else when working with electricity. Electricity can be dangerous, and it's important to take all necessary precautions to prevent electrical shock. Always turn off the power to the circuit before working on any electrical wiring. Use insulated tools, wear rubber gloves and eye protection, and never work on electrical wiring when you are wet or standing in water. Consider a whole house surge protector. Surge protectors safeguard sensitive electronic equipment from voltage spikes. Consider that future upgrades to the bathroom might necessitate electrical modifications. Planning ahead can save time and money in the long run.